So sometimes it's helpful to find y'all hear that? Sometimes it's helpful to find the equation of a tangent line. So we were finding equations of lines earlier today, and we used this form. You see it right here? This form right here. So we are going to use that again, but the thing is, we are going to be wondering about the slope. Because right now we have the equation, they're asking for the equation of a tangent line. So immediately I'm going to put the skeleton of this problem in. The skeleton of the problem is going to be y minus something, yes? Yes. Equals something, x minus something. You see how I set up the skeleton of the problem? That's how it's going to look. The question then becomes, what is my x value, my x1 and my y1, my x values that I'm going to use here? What are those going to be? Well, did they give you any of those things? Did they give you an x or a y? Yes, Olivia.
They gave an x.
So my x1 is 1. But did they give a y?
No.
No. Could you find a y from the information at hand?
Yeah.
What would you say the y is?
2.
2. Perfect. So you now have the 1 and the 2. And where are we going to put the 1?
Well, next.
Here, right? And we're going to put the 2 here. Any questions so far? Doesn't all this make perfect sense? This is pretty easy. Okay, here's where I lose everyone, and everyone's like brains like explode at this point. And it's so difficult, but it's really not. Okay? We simply need the m, right? We simply need the slope. So tell me what you know about the slope of the tangent line. Of the tangent line. What is that going to be? The derivative. So I need the derivative. I need the derivative, which is f prime of x. But what do we want to plug into that x? What is the x value that we're doing this at? Right? You just want to plug in a 1 there. So we're going to need to go ahead and find the slope of the tangent line, the derivative. So we're going to need to use the definition of a derivative. So does anybody have it memorized? Can tell me what I got to do here? Yes, Annette. Good job. And it is the limit, oops, it is the limit as h goes to 0. So we need to figure out f of x plus h. Well, we have f of x only right now. We have f of x itself, which is right here, right? Here's f of x. So the question becomes, what is f of x plus h? Olivia, what is f of x plus h?
It is 2.
Yes.
Divided.
Yes.
By x plus h.
Good job.
Minus.
And we can keep going if you want. Yep.
Minus 2 over x. Divided by h.
Perfect. This is called a complex fraction. We don't love this part. This is where all the work is involved, okay? But again, we kind of have done this a little bit, yes, at this point, finding the derivative. So there's only one missing piece of our tangent line, just FYI. And it's going to be the slope right here. It's going to be the slope of the tangent line. That's what needs to go here. So we're just working on that part right now. So what are we going to do with this problem over here, which is our current issue? It's a complex fraction. It's a fraction in a fraction, which is not ideal. Olivia, thoughts?
You should try to find the denominator.
So 2x minus 2x plus h all over x plus h times 1 over h. I'm going to explain in a minute, okay? I know that was a lot. I will explain now. Okay, so let's look at what I did. See if you can understand how that happened. That's a lot going on there, okay? But it is correct. So it's 2, and I multiplied by the x on the left side here, right over here, okay? So I put the x, I multiplied by here, x over x, okay? And then here, if you think about it, so I multiplied by x over x here, and then here I multiplied by x plus h and x plus h. Does that sound okay? And then I didn't want to have this hanging out in a complex fraction, so instead of divide by h, I times by 1 over h instead. Okay, that's all. Just to make it a little neater. So that's where we are at right now. So let's try to simplify. Are we going to be able to cancel anything out if we do this? We got 2x minus 2x minus 2h all over x, x plus h, 1 over h. Limit as h goes to 0. What are we canceling? Anybody? Thoughts? Yes, Alexa.
The 2x's.
Good. The 2x's are now gone. We have what right here? Negative 2h. Negative 2h over x. X plus h times 1 over h. What can we cancel now? Yes?
The 2h's.
Good job. So this is really our issue, is we have this limit problem. Am I going too fast, or is this okay?
This is good.
Not bad. So now we can plug in the 0, and we have what for our derivative? What is our y prime? Y prime is equal to negative 2 over x squared is our derivative. This right here is going to give us our slope. Agree? But our slope is constantly changing. Why is our slope, which is that equation there, why is our slope not a straight up number like it was in 9th grade? Why is it something different now? Why is our slope different all of the time? Yes, tell me a little bit.
I just have a question.
Go ahead.
I don't get how you, like, where did the x plus h go? Like, how you got negative 2
This.
over x squared, because wouldn't it be
This.
x squared plus xh?
That's a 0.
Oh.
So that's not gone. So I have negative 2,
okay.
right? I have negative 2 over x times x. Because I'm taking the limit. Yes?
Wouldn't it always be changing because the graph is always moving?
Exactly.
Forward, it's always-
Exactly. So we don't know what the slope of this tangent line is yet until we look at the x value. And the x value that they gave us was 1, yes? So I need to plug 1 into that graph. I need to plug 1 into this to find the actual slope at that exact time, or at that exact position. So when I plug in 1, what do I get for my slope? My slope, bless you, slope when x equals 1 is the big question. So that's y prime equals negative 2 over 1 squared, which is negative 2. That is the slope when x is equal to negative 1. So where do you think that negative 2 is going to come into play? The m in the line, right? This particular line now has an m of 2. The m is going to be negative 2. So we're going to go back here, and we're going to replace this question mark now, because we know what the slope is, with a negative 2. How's that? Yes, Annette? Sure. So you were okay to, I'm assuming, here? Okay, so what I did was I took this, which is the slope equation. This will tell you the slope every single time of that graph. So it'll tell you if the graph is pitched up like this or pitched down, because the graph is like a wave, right? It's moving, it's constantly changing. It's never the same slope, unless it's a line, a straight line. It's not in this case. So this is going to tell us the slope, but they gave us in the original question, they gave us an x value of 1, so I'm just simply putting the 1 into this equation, right here, 1 squared, so negative 2 divided by 1 squared, which is negative 2, and that's my precise slope when x is 1. So now I have my exact slope, and I can put that into the equation of my line right here. Yes. Okay. How about that, huh? Good? All right. Let's, I don't like to keep my videos too long, so stop.